Another physics video, number 5. Rolling right along. Anyway, yeah, I wanted to talk about magnetism, but it gets complicated because that gets into this charge issue. Somebody did say in a comment something, speed of light relative to what? Yes, it's always relative to the speed of light. I mean, the speed of light is the absolute. Everything's position is always absolute, and its movement is absolute, and so everything has to be to the speed of light. Every motion is relative to the speed of light. Yeah. Anyway, so it's fixed space. Well, anyway, so that's sort of the subject of this thing. I don't know if there was any other comment I had to deal with. No, I'll get to them as as they're relevant. So anyway, so the Ida Mada dot guy, pretending not to be rude. Hey, a polite critique, which I hope you won't take offense to. I don't mean to be rude. Well, you sort of do, because you're not even trying. Okay, I mean, I've given you a diagram, basically. I've said, look, imagine the matter as if there is a grid of space. So, I'm going to have to get some graph paper, and, just imagine that this is the universe. Alright, and these photon things are moving a constant, so it's essentially the Planck constant. So you could think of it as a clock speed, and on the clock speed they can move one space. Alright, and in the three-dimensional space they can do this up and down thing, and that's what they can do. So every Planck constant, they move one of these spaces. Now, whether they can do diagonals or not, I'm not going to mess with that right now. But the point is, they can do this one movement. Let's say the checkerboard can be different than this. I mean, it could just be that the Planck constant can be in any direction. That it's just a distance arrow, and that's all it is. It could be a distance in any direction. But I'm tending to think it's not. Okay, I'm just tending to think that no, it's more simple, that it is just up, down, left, right, forward, back. So that's what you're working with. All right, primarily you're working with basically a domino. Let's say a thing that flips. Okay, it just flips one space, flips one space, flips one space. Left or right, blah 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 blah, and that these dominoes can apparently, they have an ends. They have you could draw lots of different ways of describing it, right? I mean, it could just be, that they're shaped, okay, and that the shapes fit into each other. Could be. I was thinking of quanta itself just being diamonds, because diamonds end up creating lots of patterns. But that part really doesn't matter for the point I'm making here, which is the space is rigid. Okay, it's absolute. So unlike Einstein's bent space, flowing space, all that kind of stuff, no. I'm saying no, the space is rigid, the quanta are rigid. Okay, and that's where you have to start. And from that starting position, I'll read some more of your comment, but that's the starting position. I don't mean to be rude. In modern physics, it's impossible to make absolute motion consistent with the Lorentz transformations, even if you are reinterpreting the symbols in the equation to represent something else. Yeah, some of the symbols are his constant, his made-up coefficient. I mean, come on, get real. A ton of these formulas have built into them some cosmological constant, some blah 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 blah, blah, and some number they just made up to make it work, and that number probably represents some aberration created by some other mechanism that they've chosen not to explain. Anyway, special relativity doesn't just claim that no body can move faster than the speed of light. Look, light can't move faster than the speed of light. So to even talk about a body moving faster than the speed of light would be ludicrous, wouldn't it? Especially from what I'm explaining, right? So for my school of fish argument that I've already given you, certainly I don't need to hear this crap, do I? How would it be possible for the school of fish to go faster than individual fish? Oh, yeah, that's right. That would be impossible. Yeah. It formally states that the motion of a body cannot exceed the speed of light relative to any other internal frame of reference. Internal, yeah. This distinction is critical. Yeah, and I would argue that the speed of light is the speed of light relative to other speeds of light. So these things, let's say if there's one over here and there's one over here, in this fixed space, if this one moves here on the next clock tick and this one moves here on the next clock tick, yeah, these are absolute positions. They're not, it can't move here, it can't move here, it can't jump. It has to do a block at a time. Everything has to do a block at a time. The quanta has to do a block at a time, in an interval of time. So if, again, you took what I said seriously, instead of not seriously, you would understand that a school of fish has this chaos thing happening, okay? All the fish are going different directions, swirling around each other. Lots of motion, but no movement in any direction. Nothing happening. No movement. It just swirls around itself. And what I'm saying, when it starts to be moved, when it starts to go in a direction, that means more and more of these fish, so now let's represent them with little arrows, are going in the direction of the movement. And so now you have less and less ziggly stuff happening. Less and less. The faster you go, more and more of these fish have to be converted into arrows going in the direction of the movement. Now, if you start accelerating matter, which I think you'll find is that the matter itself will start to break down. The orbits of the atoms will break down. The electrons will be freed. They'll collide. They'll do all kinds of things, and I'm sure you're going to lose a lot of energy as light or photons released. So the faster you start pushing the matter, the more you'll break the configuration, the more probably energy or mass you will lose. Alright, so that's not really what I want to get to, but if you were thinking in these terms that I kind of spelled out, you would sort of understand that, yeah, motion is going to be something that's going to be revealed in the motion of the internal structure. Alright, so let's see, should I read or do? Well, I'll read a little and then do. In special relativity, if a body A is moving right with a speed of 0.9 c, we'll see a body 0.9 c. So you're saying 0.9 of the speed of light. Now what that would mean is that 90% of the fish in the school have to now be moving in the direction of the movement. They can't be in orbits anymore. They can't be in spins anymore. So 90% of the energy that was the matter, okay, the school of fish that was all wound up really tight, has now been converted into fish moving singularly in one direction. And so clearly, at such a speed, matter would no longer have any substance. You certainly couldn't push it with your finger. It wouldn't, like if it was a piece of steel, and you took 90% of the steel and turned it into photons moving the speed of light in a direction, you're going to kind of think, I think you'll be able to figure out that whatever's left of the structure of that steel is going to be incredibly weak. And that it's probably going to be rubbery and smushy, and you're not going to be able to push it anymore. It's going to be really hard to make it go faster. The harder you try to make it go fast, you're going to have to... It's like, see, Einstein was basically theorizing that matter gets heavier okay, as you accelerate it, especially getting really close to the speed of light. It gets so massive that you can't, all the energy in the universe wouldn't be enough to push it a little bit further. No, what the real argument is that once you have, let's say, 99% of the fish moving in this direction, you've destroyed almost all of the atomic structure. There's just little bits of atomic structure left. It gets harder and harder to convert those last little bits because you can't hit them. Most of the mass, most of the substance of the matter has already been converted, and it's really hard to hit the tiny bit that's left with any kind of energy to release it into the direction you're trying to push it. So it gets harder and harder to create enough energy to push through it to actually hit something, to push it further. So all the energy you shoot at it, all the energy you put into it, goes right through it. Alright, so anyway, so this 0.9 times the speed of light, it just ain't going to happen. And a body B to the left with 0.9 c times c, where c is the speed of light, they are not moving away relative to each other with a speed 1.8. Well, quite obviously. So what he's saying is, so you release a photon going this way, and you release a photon going this way, and obviously the combined distance they're accruing, will be twice. They'll obviously travel a distance that's twice the distance if one of them was going, well, if one of them never went anywhere. So if one of them just stayed home, the distance is going to be twice as much in the same interval of time. But that's perfectly consistent with the checkerboard. It's, perfectly sensible that that's what's actually going to happen. That's right. If they're going in opposite directions, they will travel twice as much distance. They won't travel twice as fast to accomplish that distance. It'll be the same amount of speed, but I mean, it's just here. You have one start. Here's the starting point. Here's X. Let's do it going this way, so I can make more checkerboards, maybe. So here you have X and you have Y. So Y goes here, X goes here. So yeah, you have this much distance has been traveled, which in an interval of time. But you have to understand that, yeah, it's important which way they're going directionally. So obviously from their absolute position, they haven't done anything magical here. I mean, it's just wrong to sit there and say this equation is correct, that you would somehow just double the number and say you've accounted, when it's very important, the vector of direction. This violates special relativity, but would be predicted by any Galilean Newtonian system regardless of atomic structure, and even if there is a cosmic speed limit of c. Well, I don't even know how that's helpful. It would be predicted by any, again, you're saying, I don't know what you're saying, I don't know what your argument is. In fact, relative to each other, the two bodies will always move away slower than the speed of light, even if they are on other side of the universe. Again, no, they won't move away slower than the speed of light. I think that's just nonsense and preposterous. They're always going to move the speed of light, and you've just perceived them the wrong way. So what did I want to get to? I wanted to get do some more with this absolute motion thing. It was an important point. Now I can't remember what it was. Damn. All right, so I did the Einstein thing. Oh, okay, yeah. So I wanted to do the absolute movement thing. Okay, so he has these, V and U are the speed of the different bodies, and again he's doing this speed of light thing, like somehow you could move bodies at the speed of light, and you just can't do that. So he's saying here, the Lorentz velocity transformations first derived and then theoretically by Einstein, states theoretically by Einstein. See, again, so this is all theoretical crap. They can't do these experiments because obviously you can't move matter. at the speed of light. It's not matter anymore. It's energy. It transforms relative motion of one frame to another. So if a body A, it has a speed of v, and v, as in pointed out here, is I don't know what v speed is, velocity, and body B has a speed uv, gives the velocity transformation between the two frames. Notice that if v equals c, see, if v equals c, right there, you can't, v can never equal c. Unless v is a goddamn photon, it can't equal c. So it's just pointless to do this equation. It's nonsense. This means that regardless of the speed of u, body B, the relative motion between the two frames cannot exceed c. Well, quite obviously it can't. But again, my model will tell you that the distance traveled in the same amount of time is going to be twice the distance if one of the bodies was stagnant or stable. But that's obvious, isn't it? I mean, how could you sit there and say that the two things are moving faster than the speed of light because they've traveled more distance when they're going in the opposite directions? Of course, they're going to travel more distance when they're moving in the opposite direction. Huh? Well, I'm not going to bother with this part. Please correct me if I have misinterpreted your system. I'm not saying you're misinterpreting. I'm just saying you're forcing me to apply my system, my statement, to math that has presumptions in it that I say are completely wrong presumptions. So what can I say? Alright, so let's do a little work on this absolute speed thing and the significance of what I'm saying. So so we have lots of different motions. Alright, I just moved this pen. Alright, we know this pen is on planet Earth and it's rotating. We know this pen is on planet Earth and it's spinning around the sun. We know this pen is moving on planet Earth, and that the entire solar system is moving in the galaxy. And we know the galaxy is moving in the nebula. And we know the nebula is moving in the universe, let's say. So you can have 10 levels of movement. And so let's represent that as vector arrows or something. Just imagine them in 3 dimensions and of different weight by their length. How much movement is in that actual direction. And so let's just make up 10 arrows here. Alright, so those arrows, it's not 10, but you get the idea, would when you calculate them, create a net vector. So let's just say this is the net vector. When you total these up, the cancel each other out, the bendovers, the this, the that, the whatever, you get a net vector. And that's the absolute motion of the object, the matter. So this pen has an absolute vector. Okay? And the point is that absolute vector doesn't really mean too much. The speed of this vector is not going to be the speed of light. It's not going to be anywhere close to the speed of light. It's going to be 1% of 0.005% of the speed of light. It's not going to be some kind of gigantic number. It's going to be a big number, but not a gigantic number. And the point is that what's going to basically happen on the checkerboard, okay, back to the checkerboard, and an atom structure. Alright, well, I don't know if I can do the atom on the checkerboard. Alright, so just pretend that this is going to, use your imagination a little bit. The point is that, okay, so you have, let's say, the nucleus of the atom, and let's just make the electron simple in the sense that it's just a string of photons moving the speed of light. Obviously, they're swirling in a loopy-doopy, circular spring pattern of some kind to absorb some of their speed. Okay, but the point is that each one of those photons is moving absolutely one square at a time. So the point would be is this absolute vector of direction has to be affected. It will be affected. All the atoms in this pen right now, all of them, have a representation of absolute motion in the sense that the shape of this orbit is in the direction of that vector. So in reality, when this electron spins, so let's say it's got spin, so it's spinning, and let's open it up a little bit. It's spinning around the nucleus, let's say, of the atom. It's not really a nucleus. I think it's just another loop, but whatever. We're not getting into protons now. So let's just deal with electrons. But anyway, the electron is spinning. The photons in it are turning and twisting. And the point is that more photon distance will have to be in this direction, okay, than in this direction or that direction or that direction. So for every 10 Planck constants in this direction, it has to do 12 Planck constants or 15 Planck constants in this direction. So this orbit is constantly going to try to be eating space in the direction. So that's what this opening does. It's just eating space in that direction. Okay, so it moves further, it moves more squares going this way. And as it does that, the back end of its orbit is shortened. And so now its center of gravity keeps changing, and that's going to force its nucleus in that direction. So the force will be transmitted into the molecular motion of every piece that's connected to the system. But all the photons, all these things are made out of photons. So all of them are moving in this direction, more squares than any other direction, and still maintaining their structure. And it's only when you get to enough absolute speed that you would destroy the function of the matter. Okay, but it has to be, it's a lot of speed. I mean, let's not, it's a lot of speed you need to get anywhere close to where you're starting to degrade the matter enough. But we can see that we're pretty warm. Our matter is pretty energetic, and it's probably because there is a substantial amount of this jiggling motion created by all of these influences that are part of our momentum. And that momentum has the price of a kind of instability in the atomic structure. And that's probably why electrons can be emitted and photons can be emitted from electrons. And that's probably why it is as active as the chemistry is because we are so deep in a motion cycle. And that if you were just in space and you weren't being pulled by something or moved by something, the matter would be so cold, that the orbit would be so stable and so locked that there could be no opportunity for any chemistry. Very little activity. Something like that. But anyway, the point is that there is absolute motion, and everything has to work on this closed space. And there's no need to time dilate or do any of this kind of stuff. It's not a problem. The quanta themselves, the bits moving, the speed of light, will dictate the direction through how they navigate the direction. And if they're going to have to navigate a direction by doing something like that, then their internal speed, this will create resistance to any more momentum in that direction, because again we get to this argument of once something's moving, it's going to get harder and harder to push it the more the matter degrades. But again, all the quanta themselves can't do anything but move that one Planck constant in a direction, and they're the ones doing the movement. Matter doesn't move, the quanta in the matter moves, and it has to move by the rule that none of it can go faster than the speed of light, and therefore the parts that are therefore you're going to have to lengthen orbits, you're going to have to change their shape to create movement in a direction. So if you want to have movement in a direction, the orbit's going to have to be changed. It's going to have to be shortened on this stroke and lengthened on this stroke in terms of how many Planck constants, how many squares of space you eat. You have to eat more in one direction than you eat in the other direction. And that's basically every bit of matter probably reveals, if you could actually see it, would reveal its absolute motion. It would be revealed in the shape of the standard orbit of its electrons. It's probably revealed in there. If not in the electrons, then in the rotation of the photons inside of the electrons. Okay. Yeah, this is getting more technical, but like I said, this is a technical bit of crap, so I have to get more technical, right? I don't really want to do it that way, because I think the more important theme is that I'm saying there was wrong premises made. I'm saying again, go back to the Einstein riding the light beam metaphor. And what Einstein should have been thinking about is what's happening to the matter he's made of as he starts moving faster and faster. And I think if he would have thought about that, he would have thought about the idea, just because he knew this idea that a photon is released without momentum. The movement of an object, it doesn't matter how fast this thing is moving, it doesn't matter how fast your vector is. If a photon is released from an electron, it has none of this momentum, because it's just like a moon being released from its gravity. It wouldn't have extra speed. It would have exactly the same as its orbiting speed. So the moon's orbiting at a constant speed, and if the gravity stopped, it would just shoot off in a straight line at the same exact speed it has. It could not carry with it any extra earth speed. There'd be no extra speed. There'd be exactly the same speed it's traveling at, and all that would be decided is what direction it would be released at. So that's another point I wanted to make, that some guy keeps brought up forces. Maybe this is the next. Yeah, here it is. What does charge come from? Well, that's a function of the migration of electrons and the strong force. And if you want to talk about the negative or positive, you want to talk about protons and electrons, that charge is different. The charge that binds things. Strong and weak forces. Yeah, let's not combine all this stuff in one question, right? Isn't that kind of just a bogus thing to do? The word charge, you got to be really careful on how you use this word charge, right? Because charge is just a representation of how many electrons you've piled up on one end of something, and that will represent a charge. Okay, what charge what's the state of the electrons themselves is another question, as if they could carry a differential amount of force to their charge. They could be more heavily or lesser weighted electrons. You make way too many lavish and broadly claimed arguments. Well, again, I don't know how else I'm supposed to do that exactly. So you make a lot of snarky and assholery remarks. That's pretty much all I have to say to that. I don't really know how. I've given you a pretty simple and broad description. What I'm basically saying is this dilation of space based on this mass idea and using dimples in space is a wrong metaphor. I've given you a simple little school of fish metaphor, which I think much more accurately describes what matter is, which is a whole bunch of energy just trapped in a bunch of nonsensical patterns. And that's basically what it is. And when you straighten those lines, you convert the matter into energy. I don't think that's too simplistic or too complicated. I think that's exactly as much information you need to describe a circumstance. And so you're just being a naysaying, nitpicking, weaselly little bastard, suitable to your whatever, this Nazi image you got. The idea of physics is to describe a situation as simply as you can. Now, did I do it more complicated than I needed to here? Or did I try to make it too simple that it couldn't be understood? I don't think I did either one of those things. I don't think I've done either one of those things. I've got 9 little talking points. I'll probably add a couple more representing this. So your complaint is just nonsense. Sorry, but that's all it is. It's just a nonsense complaint. You could do this to any single person who ever proposes anything different. Oh, evolution's too complicated. Oh, it's too this, it's too that. Fuck you. Anyway. As simply as you can, look up Doc Schuster if you want to learn physics. Yeah, well, fuck you. You learn manners. Look up Miss Manners. Maybe she should teach you some fucking manners, Matthew, you little fucking weasel. Fuck you, steamroller. It's all you deserve. You little rude, obnoxious putz. You said nothing in this. Nothing. There's no counter argument. Nothing. Absolutely nothing. Sorry I wasted time with that. Anyway, so I did want to get to this idea of force and direction. So the basic concept here is that energy is photons moving. Alright? Things moving the speed of light. All energy, all C equals energy. Okay? Energy is C. It's stuff moving the speed of light. Alright? I mean, let's not get confused with mass, because mass is a function of when you trap energy, not a function of how we describe energy when it's been released. But quite obviously, if energy hits me, okay, massless energy, a giant school of photons comes screaming at me, and it technically has no mass, it sure as fuck is going to have mass when it hits me. So let's not play this, you know, these people keep making these idiotic arguments, photons don't have mass. Well, quite obviously they do. They can burn your skin right off of your bones, you crazy, stupid fucks. Why don't you look at a nuclear bomb exploding, and look at a picture of like a mannequin, and just watch the vinyl fried right off of it by photons with no mass. Anyway. Alright, so what a force does is just change direction. So again, we're just talking about these things are spinning, and we're just talking about release points. So something comes in here, this direction, and something's released in this direction. And forces are changing the direction. But that's all that's happening in this school of fish, is that you can change the direction of fish. And you can change them coherently, where you change the direction of all the fish, or you can chaotically just release fish in different directions, or even packets of fish. But I mean, it's just change. Forces just control arrangement. They don't control energy. They don't change the energy of a system. So forces never change the energy of a system. They just change what is released. Where the energy is released, how much and in what direction the energy is released. That's all forces can do. They don't add energy. They just control release points. Okay. Yes, that's enough. And amount of what's released. Yes, that's enough for this video. Alright, so till next time, I do appreciate, like I said, rational counter-arguments, okay. You can even do some of this, well, what about the Horowitz, blah, 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 blah. And I suppose this is a reasonable way to do it, because at least you put all this C stuff in here just to point out that, yeah, well, I'm not going to, I have no obligation to play with math that my theory says is preposterous. A school of fish, again, it's not possible for it to move faster than an individual fish. It's just not possible. Anyway. So there's just no point doing math about it. Anyway. That's enough. Yeah. So until next time. Maybe we'll try the magnetism thing. That's going to be a tricky one, you know, because I think it's the same force as the gravity. I mean, it's the same mechanism. So you got a bunch of this pressure. And what's happening is you're changing the pressure gradient of a piece of matter when you have a charge on it that changes this potential. So you shove all the electrons to one end and you have a bunch of protons at the other end, let's say, because the atoms are still there, and that they absorb the photonic pressure at a different rate, based on the density of these electrons. You still have to come up with the repulsive thing, where the two magnets repulse each other. I think that's doable. I just have to, it gets really convoluted when you start thinking about, okay, so you have extra pressure here and you have less pressure there, and, doing that pressure gradient thing can get a little complicated. But the only way the structure can tune in to the photons to block any at all is it has to do this separation. It has to force the electrons out of the way, so to speak. Push more of them out of the way. So more or less can be well, anyway, I'm trying to do the video now. I have to think on it before I do it. It's a little more complicated, and you got these, the whole field that's more defined, which I'm thinking might be related to the fact that I think the gravitational photons might be at the high end. They might be like cosmic ray style pressure, and I think the magnetism ones are low end radio waves, undetectable radio waves so low, so long a frequency, that we don't have instruments to detect them besides pieces of steel that become magnetized by the radio waves. Alright, I'll get to that next time, or something else, or we'll see where it goes. So, see if we can get somebody real to make a real counter-argument. See if somebody's got any balls at all. Obviously, Warble's on a lot has no balls. Yeah, it is kind of ironic, right? Because when he did his little sunfoil thing, I watched all of his videos before I critiqued his crap. And he couldn't even watch my one fucking video, and he just talked out of his ass. I mean, just amazing. So this is a guy who wants somebody to take him seriously, who says, I'm going to change the world with my sunfoil, and yet he won't give somebody else making a claim 1/100th of the respect he's expecting. Amazing. I mean, the hypocrisy and duplicity of these people just has no bounds. So anyway, till next time.